This assessment asks us to take a Newman projection and convert it into a line angle structure. To do that, we'll orient ourselves from a particular perspective. For this one, let's orient ourselves looking at the molecule from the right side. We will draw a dashed line through the center of this molecule, splitting the molecule into a northern and southern hemisphere. That will help us determine where in our new line angle structure these substituents will go. We'll start by drawing the carbon A-carbon B bond. Because we're looking from the right and carbon A is closer to you, carbon A will be on the left side of our new line angle structure. Looking at the substituents on carbon A, the bromine is pointed up into the northern hemisphere, so it will be in the northern hemisphere of our new line angle structure. And it's on the vertical axis of our line angle structure. That means it will be an in the plane bond in our new line angle structure. Bromine then will be attached to carbon A in the northern hemisphere on an in the plane bond. The hydrogen down here on the bottom right, if we're looking at the molecule from the right, is going to be closer to us as a viewer, so it will be on a wedge. It is down in the southern hemisphere of the molecule, so on carbon number A in the southern hemisphere on a wedge, we'll have a hydrogen atom. The CH3 group on the bottom left, if we're looking at the molecule from the right, will be further away from you as the viewer, so it will be on a dash. It's also attached to carbon A, and it's in the southern hemisphere. So on a dash on carbon A in the southern hemisphere, we will have the CH3 group. Now we can add the substituents to carbon B. First thing I notice is the hydrogen on the vertical axis. That means it will be an in the plane group in our new line angle structure. The hydrogen, however, is down in the southern hemisphere and attached to carbon B. So attached to carbon B in the southern hemisphere on an in the plane bond, we'll have the hydrogen atom. The CH3 group is on the right side, so if I'm looking at the molecule from the right side, it is now closer to me as the viewer, so it will be on a wedge. It's in the northern hemisphere and attached to carbon B. So on carbon B in the northern hemisphere on a wedge, we will have the CH3 group. Finally, this last hydrogen over here on the top left of the structure is now further away from me as the viewer if I'm looking at the structure from the right. So it will be on a dash in my new line angle structure. It's attached to carbon B in the northern hemisphere. So attached to carbon B in the northern hemisphere, I will have this hydrogen atom. This converts this Newman projection into this line angle structure.